promised, at least if you follow Wolfgang on Twitter, which you should, I was promised rubber ducks.
There was rubber ducks. There will be rubber ducks. Yeah.
So I think this rubber ducks, I think, is just going to be the ultimate. That and security culture development is actually going to be a great way to end our opening day here.
Oh.
So thank you very much. We'll take it away.
Thank you. Great conference. What's this? Free hugs afterwards from that guy. You heard it. He just volunteered. What a guy. What a guy. Huh? Let's do this. All right, security culture and development. My name is Wolf Goerlich. I am a strategist with this company. We do IT risk management. I do a lot of things in the community. I'm involved with MISEC. You guys ever hear of MISEC, Michigan Security Community? Yeah. So, and OWASP Detroit co-founded that for getting developers, into security, getting them some knowledge, some information. I was really bummed I missed the OWASP Detroit meeting on Thursday driving down here. But so definitely, if you guys are enjoying yourselves, if you're new to the community, check a look at the local IndySec, check a look at the local OWASP chapters. Some great things going on in your backyard. I'm also one of the people behind the B-Sides Detroit and Converge conferences. And Converge and OWASP, they share a lot in common. So Converge is for DevOps. And like OWASP, what I'm trying to do is figure out new ways, better ways, that we can bridge that divide between developers and the security practitioners. And it is a big divide, right? I mean, right now, today as we're talking, right now there's a conference somewhere for developers. And right now as we're talking, these guys are really, really excited about something that's going to freak the hell out of us in 3 years. And as a matter of fact, if you guys listen as you're going through the Circle City tracks, some of the vulnerabilities you're going to run into, you're going to be like, what the hell did they do that? Yeah, that was at like CodeMash 3 years ago. That was the new shiny thing. Right? This is incredibly important that we get in front of developers. So, anyone here, did you guys go to the Hacker Family Dinner yesterday? So that's another thing, go to the Hacker Family Dinner. Tim, who is graciously our photographer, tweeted out that they were following me to dinner, which surprised me. I'm like, there's people following me. You should never follow Wolfgang to dinner. It's a bad idea. I will get you lost, I promise. I had my phone out. I was doing good. Luckily, one of the things I love about Circle City is a circle, right? So if we walk in a circle, it's within spirit, don't you think? I'm like, oh, look, there's like 2 Capitol buildings on the way to Tapas. This is great. So we got a little lost, but I had a great conversation. This is the picture Tim took. And there's me looking at my phone like I know what I'm doing. And I was talking to this girl over here. Her name's Carla. And a while back, we're like, so what do you do? And she goes, I don't really want to say. I'm like, no, what do you do? And she goes, well, I'm kind of a developer. I'm like, yes, high five developers. We're like, yeah, high five developers. And she goes, what do you code? I'm like, I kind of don't get to code anymore because I'm a strategist. And then she didn't want to high five me anymore. I think I could have got like a fist bump at that, but that was probably about as far as I was going to go. But I started talking to her. I'm like, so what do you develop? What do you make? And she's like, I make robotics. I make embedded control systems. I do this type of web service. I'm involved with this mobile app. Whenever there's a big problem that her company can't fix, they call her and her team in and they write the code for it, which is phenomenal. It was really exciting talking to her. She was very pumped up. And that's important, right? Because if you guys forget everything else we're going to talk about tonight, everything else, it's please remember this one idea. Pound for pound, brain for brain, person for person, I will put a developer up against a hacker every day. They're excited, they're passionate, they're intelligent, they're driven, they're doing cool stuff. They don't get why we're up here, breaking stuff. Why would you break a web service? People are running that. Why did you do that? I know, but it was cool. It was a great exploit. They don't quite get why we do what we do. We don't quite get what they do, but they're brilliant, right? And they have a lot of fun, and they want to move fast, and they want to ship, and they want to build cool stuff, and they want to leave a legacy. And when we talk about SDL, all those things come into play. We need to figure out a way that as security professionals, we're helping them go fast, we're helping them build cool stuff, we're not slowing them down, and we're helping them put out quality product. Vital for our success. All right, cool. So what's the problem we're trying to solve? The problem we're trying to solve is pretty well known at this point, right? Every single application we build is subject to attack. Every single application. I drove down here, Wednesday. I drove down here Wednesday. And I stopped off at a couple different customer locations, and I visited some customers on Thursday. And it was good, because my GPS works terrible walking in the city, but it works great about 80 to 90 miles an hour. It's like a really bad, parody of speed. Don't slow down, the GPS will stop. So we're raced down, met with a bunch of customers, and every single one of them had their same concern, right? They all phrase it a little bit differently, they all have the same concern. They're like, look, in the past, no one knew who we were. In the past, we didn't really have anything important. In the past, yeah, we're not really doing credit cards, no big deal. But today, everyone wants to steal our data for faking identities, for reselling it, for customer advantage, whatever it is. Everyone's stealing data, and they're all stealing it through the applications. And of course, we're delivering all those applications now over web services, which means firewalls don't really do us much good anymore, right? We're passing it all over 80 and 443. And for those of us with as much gray hair in you guys all remember, we cut our teeth, right? How are you going to be secure? You need a firewall, you need an antivirus, you're safe. But firewall doesn't do very good if it's just passing all the traffic in over HTTP. And antivirus and IPS doesn't do any good if all the traffic is over TLS, right? Because you can't view it in the packets. So a lot of our traditional controls aren't working. And we're in this point, I'm going to dig into this a little bit more in a moment here. We'll get this steady state of bad. We are really good as an IT industry at making bad stuff, and making bad stuff consistently. And not only are we good at making bad stuff consistently, but now we're making more stuff, right? The whole Internet of Things, the whole ubiquitous computing, we got more stuff than ever, and we're taking this steady state of bad and putting it everywhere, which is going to make all of our jobs a lot more exciting over the next few years. So this talk is about development processes. This talk is about life cycle. This talk is about producing defensible applications. This talk is not about security coding with examples. I'm not going to bore you guys with any of that. It's all over the place on the web. It's not about exploiting vulnerable code. I have never really been the pen tester. I've worked with some really smart pen testers. That's their gig. That's not what we're going to cover. And I'm not going to do another OWASP Top 10 talk. I promise. I am so over OWASP Top 10 talks. And this is coming from the guy who co-founded OWASP Detroit, but I just, no. They don't work, right? If they worked, we would see some different stats, but they don't work. And I think we see that with a steady state of bad. Let me give you an example of what I mean. You take the OWASP Top 10, and, SQL injection, program sites, cross-site scripting, blah, blah, blah. The talk on Thursday that I missed at OWASP Detroit was on SQL injection, some cool ways to do it, and get in an Oracle system and use SQL map. Really cool stuff. I love it. And I think hackers, we've gotten really good at it. Oh yeah, here's how you break into this, here's how you break into that. But what about developers? We've had what now, 10, 12 years of OWASP Top 10? Where you can go pull down code samples, you can watch videos, you can make requirements. What has been the results of this? I'm going to put up a chart. This chart is from Veracode, right? So Veracode does static code analysis. They also do a whole bunch of other things. But this chart is from Veracode. And this chart shows the first time a code base was scanned. So you just wrote an app, and you throw it to Veracode, and they scan it. All right? And what's neat about that is that's going to tell you how likely it is for a common developer right out of school or in the industry to make applications. So if you take a look at this chart, this is going to show the impact of OWASP Top 10. All right? Flat. SQL injection, 2/3 of the time. Cross-site script, or I got that backwards. Cross-site scripting, 2/3 of the time. SQL injection, 1/3 of the time. Right? Absolutely flat. We haven't made any difference. We're taking these kids out of college. They're producing bad stuff, which is awesome because then we can go to conferences and we can laugh at them. This isn't awesome. This isn't working. It's just keeps on going. And it's kind of interesting too, right? I mean, it's very, very, very consistent. One of the things we do at CBI is we have this thing called CBI Academy. So it's an apprenticeship program. I'm the dean of it, which I think is interesting. I want to get the leather patches on my coat. I think that'd be awesome. But we'll tell these kids, like, hey, I want you to break an application. Which one? I really don't care. Pick 10. What do you mean pick 10? Just go to GitHub and pick 10. Well, what if they're okay? They're not. Don't worry about it. Pick any 10. 6 of them will have cross-site scripting. 3 of them will have SQL injection. And consistently, time and time again, that's what we find. Very consistent. So this is from the Veracode State of Security Report. You can download it. It's got some great stats, but that's where I got that graph. is a pretty big fail. So we're pretty consistent on producing bad. We're also pretty consistent on measuring bad. There's this metric called defect density. And what defect density is how many bad lines of code there are per the code base. So Goerlich did a study. Goerlich pulled down 450 million lines of code. Goerlich looked at this code and they looked at mature code bases, new code bases, they looked at open source, they looked at closed source, looked across the whole line. And for reasonably mature code bases, not new, because new ones are going to have a whole bunch of problems. For reasonably mature ones, closed source or not, they found 0.69 defects per clock, right, per every 1,000 lines of code. So where this gets interesting is we can then predict how many vulnerabilities we're going to see. We've got a good track record of this. If you guys think about the best server ever, Windows 2003, right? Who doesn't love Windows 2003? Does anyone not have a project right now to get rid of Windows 2003? It's everywhere. The big worm that I loved in Windows 2003 was Blaster. It was the first worm that I had to face. I was a security officer at the time. It was a mess. It was a lot of fun. We cleaned it up. But what's interesting about Blaster is if you look at the code in Windows that allowed Blaster, here's what it is. Basically, just one line. They weren't doing any error checking, so if you go whack, whack, server name, whack, share, they weren't checking to make sure you weren't going whack, whack, server name, whack, share, whack, my mal code, and then running it on an RPC, which runs a system. So just one line allowed Blaster, which took out all sorts of different systems, right? It was one of the fastest spreading worms we saw. So you can take that defect density, and you can play it forward. We know Windows 2003 had like 50 million lines of code. That means there should have been around 34,000 defects, and only one of those lines of defects has to enable something like Blaster. And you think about the past 12 years of Windows 2003, we've been patching this stuff forever. I mean, you can do the math, it's pretty dang accurate. These problems, defect density, leads to a steady state of known bad. Same thing we saw with Heartbleed, right? Open source, closed source, 0.69 defects per clock. So Heartbleed was everywhere. Anyone look at Heartbleed's vulnerability? Again, it was just one line of code. They were not doing any sort of error checking, and they're silent discarding the excess. One line of code allowed us to read systems from HTTPS all over the place. Still in the realm of HTTPS, back to closed source, go to fail, another example. I don't know if this counts or not, because actually the one line of code was an extra line, but you get the point. All it takes is one line and we have an issue. And it was only 0, 6.9, consistently year after year after year. So we're failing there too. So now we can project this forward. We got a consistent known bad. We got a consistent rate of defects. And now we're making more and more and more devices. Think back to that developer I was talking to when we walked to the Hacker Family dinner. I'm like, hey, what do you do? She didn't go, well, I am working on client-server applications that sit behind a firewall and only talk to the subnet that you let it talk to. It's the newest thing. No, she's like, I'm doing robotics. I'm doing embedded systems. Everyone is doing cool stuff that is outside of our data centers, is plugged into our walls, our houses, our homes, and everything else. The Evans Data Corp put it at 1 in 5 developers right now are working in IoT. And of course, now we're seeing a whole bunch of different problems with it. 2 years ago, I was at Confu, which is in Montreal. Great conference, a lot of fun. And the demo that the guy was showing was just turning on light bulbs. On and off light bulbs. He built his own IoT rig for it and everything. I'm like, so that's pretty cool. Are you doing any bounds checking? He's like, well, no, right now I just want my light bulb to turn on. Awesome. I know what we're all going to be talking about in security in 2 years. This is great. So the IoT space, of course, is going like crazy. There's something like 4 to 5 billion of them right now. Gartner says there'll be 25 billion by 2020. Is that true? I don't know. But again, between 5 billion and 25 billion with all the same problems over and over again. And we're writing one single line of code to increase our attack surface. One single line of code will get us in, and now we're going to deploy that one single line of code across millions to billions of devices. We're going to have a lot of fun in security over the next few years. It's not going to be boring. It's not going to be deploying a firewall and we're safe. So what do we do to fix this? One of the things that I find very interesting about security problems in general is moving from the technical side into the people side, right? And that is the security culture. And that's what I want to kind of look at today and then dovetail that into how it could fix security, and then we'll talk about rubber ducks. So, I already mentioned all this. Known bad. Why is this happening? It's all about culture. It's all about culture. When I was at the financial services firm, I managed the dev team. I took over the dev team, and I was looking at some of the code blocks. They had a knowledge base that was really nice. We want to connect to a database. We always connect in a consistent way. We copy the code out of the database. We want to throw up a web form. No problem. We always do it the same way. We type the code out of the knowledge base. This type of tribal knowledge is fantastic for developers because they want to go fast, they want to build a good product, they want to ship. They grab the code that someone's already built, they put it in a thing, they massage it a little bit, they go. It's cookbook style coding. Fantastic. Except for most of it is vulnerable. Right? When we scan that knowledge base, vulnerabilities all over there like you wouldn't believe. And some of those codes were going back to mid-90s, right? There's things in there that someone decided, well, we really need a high timeout because of our, 10 meg network that was still in there. Yeah, you got the same things like the 90s? Absolutely. Right on. It doesn't go away. So when thinking about culture change, one place to look at is the Security Culture Framework. Security Culture Framework is an open source framework. It was put out by the Rower Group. Right now they're on version 1. Version 2 is actually being launched officially. The working group for version 2 is being launched officially next Thursday in Oslo. I'm actually flying out there. I'm giving this very similar talk to this. And what it does is it looks at any type of security behavior from a results metric, right? Not, hey, how many hits do I have in my firewall? How many spam do I have across my gateway? How many times did someone try and access the wrong file? But rather, are my people not clicking on links? Are they following policy? Are my developers writing good code? So results-based metrics, planning out activities that drive those metrics from a series of topics. So this is the SCF. I'm going to jump back to it several times. Well worth taking a look at when you're talking about driving behavior in a security program. And then we have the SDL, right? The development life cycle. Several life cycles out there. Because I'm an OWASP guy, I'm going to look at the OWASP one, which is, hey, how do we build our code, do the threat modeling, do the risk assessment, figure out what our security and privacy requirements are. Do static analysis, so we're banging on that code as it's being built, looking for bad, right, running across rules, tying it into IDE, so when developers are typing and doing what they're doing, they get instant feedback, here's our problems. Application pen testing, so someone's beating on it and finding the vulnerabilities that the code analysis is going to miss. Remediating it, putting it into dynamics so it's constantly checking it, putting up firewalls around it, monitoring it, running it, and so forth. Standard development life cycles start to end. I love life cycles. I do. I talk about them way too much probably. But I think if you're going to do something, right, we might as well figure out the way to squeeze the most value out of it, produce the least amount of work out of it, and get some good results. And of course, then we ship a product. But the product doesn't go away, just like Windows 2003. It shifts from being this lovely baby that everyone loves to this old man. And back at OWASP Detroit, we had a talk, a guy named Mo, love Mo to death. His handle's Nerdy Beardo. He's got like this Beardo bunch with his family, with all his beards and everything. It's really hilarious. But anyways, he called me out. He's like, Wolf is always talking about life cycle. He's like, yeah, I'm always talking about life cycle. And he's dead wrong, because really it's all about life support. It never freaking dies. Just like Windows 2003, we run it forever. Windows XP, a lot of people still have Windows XP. Probably people still have Windows 2008 20 years from now. Once we put in place, hey, here's how you connect to a database in 1990, we can be assured that the culture change is going to make sure that they do that again and again and again. So it all comes down to how can we drive culture, manage culture, get the right things in people's hands so that when they leave, and the people they train leave, and the people they train leave, and we're 3, 4, 5, 6 people down the road, security is still being considered, and people are still doing the right behaviors. Even if they don't know that the reason why they check this box is to prevent cross-site scripting, they're checking the box every single time. That's what we need to get to, which ends up being basically a security culture framework plus SDL. And that's what we'll talk about next. Before we get to that, jumping back 1 second, let's talk real briefly about maturity models. Okay, so there's 2 of them we're going to talk about, vSIM and SAM. vSIM is building security maturity model. vSIM, what they did was they actually looked at 67 really well-run security programs. They looked at them, they teased them apart, They had like 975 people ask a whole bunch of questions and analyze the data different ways, and they built out this model that prescribes, or rather describes, how security is being done at these really well-run places. They're version 5 now, released in 2013, you can download it for free. And it looks something like this. Blowing up that graph, it basically gives you a radar graph on a maturity scale, 0 to 3, for everything from strategy, training, standards, you get the idea. So that's BSIM, right? Let's analyze people who are doing a really good job. Let's codify it. Let's push it out. The alternate to that is SAM. SAM comes from OWASP, Software Assurance Maturity Model. SAM took a different perspective. They interviewed hundreds of different security initiatives, getting some of the ways that they're doing it, and finding what was working, what wasn't. They wrapped it up into some prescriptive guidance. Version 1.0 was released in 2009. Again, you can download it for free. There was about 21 people who were involved in that. So OWASP was involved with SAM. SAM's the one we're going to use for this. SAM or BSIM, take a look. If you guys are building a program, figure out what makes sense for you. SAM does is it breaks it down into basically 4 different business functions: governance, construction, verification, deployment. Each one has different security tasks. So under governance, you're doing things like security metrics. Under construction, that's where you're doing your threat assessment, your threat modeling. Some of the things we heard about in the last talk, gathering good threat intelligence and then feeding back in to make sure that we're preventing those types of attacks from happening again in future products. Developing a security architecture, what have you. Then we've got design review and code review, right? We're beating on it, we're pen testing it, we're doing all the things that the red team loves to play with, and then we're on to life support. It runs and runs and runs in an operational environment. We're hardening it, we're looking for vulnerabilities, and we're keeping it going. So, that's a maturity model. So what? If you look at a maturity model as a goalpost or as a point to reach, and then we reach back and start thinking about the security culture framework, we can use that to build the steps we need to get to lock everything down. It's pretty simple. You just select your security model, right? It's choose your own adventure. Evaluate the current development program. How close are we in these areas? Create a gap assessment. All right, we need a lot of work over here. We don't need much work over there. Divide it into tasks. Rank and prioritize and create the roadmap. Key thing here, like I was saying about developers in the beginning. How can we create this roadmap in a way that does not add to their workload? How can we shift time, maybe change up some of the things they're doing, but not add more to their plate? They are just as freaking busy as we are. So how can we create roadmaps that are achievable with the resources we have, are not something crazy like we're going to rewrite all our policy and rewrite all our code, and can be achieved? Because every time I've seen a software development program fail, that's what happened. They had this great image. Oh, I read BSIM. BSIM's awesome. We're going to do BSIM. Fantastic. Okay. Now, all you developers, I need 20 hours from you over the next 6 months. Done. Done. Not going anywhere. It's dead. All right. So that's step 3, leverage that culture framework, right? Use the SCF to roll those changes in and track them from a cultural perspective and implement them in a quarterly cycle so that we're following along. Again, this is what the SCF looks like: organization, topics, plan, and metrics. From a metrics perspective, defect density, which I was always talking about, is a great one to track, specifically critical defects, highs and mediums. Yeah?
So I actually have a question. So I'm aware of like a very
Yep.
defect density, but from an OWASP, like a web application perspective, where do you get defect density data?
So if you're doing static analysis and you're building your application, the question was, where do you get defect density from like a web application? So if you've got your application and you're doing static analysis, let's say, and you're highlighting all the defects within that application, and then you're counting up the lines of defects versus the total lines of code, there you go. But when you do that, though, some of those instances are going to be critical, right? Hey, I could steal data out of it based on my threat model. I know that I could get at social security numbers, credit card, whatever it may be. Some of them are going to be low. Do you know that if you don't have a strongly typed assembly, no one cares about that. So that's why it's critical, high, and medium, and tightening it in to things that actually matter. Make sense? Sweet. All right. So once you've got your metrics, we need our topics. The way to do the topics is to do that gap assessment. Here's our program. Here's what we want. What do we need to do? And then plan how they're going to roll in using a roadmap. And again, figuring ways as much as possible to reduce the impact on the developers, reduce the impact on the security team, not add time to the process, not extend the build cycle. An example, and this is kind of an eye test. This is right out of the SAM download if you want to grab it. But you can see here they got phases, right? And we're ramping up on security metrics, and we're doing some education and doing our threat assessments, graphing it out, and tracking the maturity over that process. Good? Any questions on that so far? Sweet. All right. So now we're going to do a quick case study, and we'll wrap, because I think, it's 6:30. All right. So for my case study, a fictional shipping company, a very fantastic shipping company, I might add. It's called Sitting Duck Shipping. Tell you a little bit about Sitting Duck Shipping. They're a great company. Sitting Duck Shipping made its mark by shipping with ducks, hence the name. Everyone loves Amazon, the drones, but what does the drones not have? They don't have rubber duckies. No. When you absolutely positively must ship by rubber duckies, you ship by Sitting Duck. I always want to write on that duck, but now I'm getting distracted. All right, so Sitting Duck Shipping. They've been in business for a while, but now they're starting to lose money, right? And that's not good, so they got to put in place a new project. We're going to look at the SCF, and we're going to look at that gap assessment to topics, that roadmap to planner, which means rolling things out in phases. We're going to cover 3 main phases, well, 4 if you count, not by 0, which I did here. We're going to start with greenfield development. We're going to do some static code analysis. We're going to address the technical debt. We're going to do some dynamic testing and really tune in the program for moving forward. This is a super fast e-commerce site. They're concerned about losing business to Amazon. And I always imagine like the CEO of this company has like a Palm Pilot that he just recently had to upgrade to a BlackBerry. He's got like the manual keyboard, hates it because it's too technical. And he does indeed call it e-commerce in my head. We got to do that e-commerce thing. I hear it's great. So, all right, so we're going to build an e-commerce site. Here's the reason why that's important. I've seen a lot of successful SDL programs. I've seen a lot of bad SDL programs. Most of the successful ones have started with new code. A new project, a skunkworks project, something's getting off the ground, there's room to play. The reason is the developers are not too heavily pressured yet, right? We don't have a lot of technical debt yet because it's mostly greenfield. We're writing new code, we can get some buy-in, we can buy some time, we can set expectations, we can have a schedule that allows us to do it. So for this particular case, we're going to start with the greenfield development. About the first month, we want to go ahead and look at how Sitting Duck is building code. Way to do that is that static code analysis, be it Veracode, be it HP Fortify, IBM AppScan, whatever it may be, scan that code looking for common vulnerabilities. Existing code, right? Not the new code, but existing code. And come up with not the OWASP top 10, but the Sitting Duck top 10. What is the top 10 ways our organization is making mistakes? What is the top 10 ways we are training our developers to write code that allows criminals to steal from us? Let's start with that top 10. So we'll scan the entire code base. We'll group all those up into 5 or 10 things that we're going to then teach the developers new and better ways to do, going into a clean code base. There's going to be lots of criticals and highs when you scan an existing system. So if we got this new e-commerce site, we got this old legacy web app that's still out there running, we scanned it, oh my God, there's SQL injection everywhere, there's cross-site scripting everywhere, there's a reflection attack somewhere, blah, 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 right? Everything's bad. So what do you do with that? We don't tell the developers that. We make them aware of it, but we're not going to burden them. Easiest thing to do is do like a virtual patch with a web application firewall. Okay, we know the issues are, we're going to plug it into our web application firewall to stop and prevent those issues. Not a fix, not a fix. Anyone here played the RUCTFE the past couple years? No one? Oh, you guys, one guy. Good, thank you. It's fun, isn't it? You guys got to play the RUCTF. I don't know if anyone sat through the CTF training. The guy who led the CTF training was the MySec coach. This past year, the year before that, I was the MySec coach. And basically, it's put on by Russians, which automatically should get you guys excited because Russians are never boring. And they give you this web application. You're Russian. You're like, yeah, I know, I'm never boring. Yes. Yes. Crack open some vodka. Let's do this thing. So They give you this web application, and it's vulnerable as all hell. It's like the worst, I mean, terrible remote access. Ugh. And they give you like 5, 6 of these things, and your job is to keep them up, keep them running, while everyone in the playing field tries to take you down or steal data from you. That's the whole game. And we knew going into this that we didn't have probably the strongest developers to fix the problems we're going to find. So we had a web application firewall. And out of a 10-hour event, for about 6 hours, 6 glorious hours, we didn't lose any data. Because we scanned it, we found the vulns, we threw it in front of a web application, and it was stopping everything. Until someone figured out we had a web application firewall. In the next 4 hours, we got clobbered, but it bought us 6 hours. And you think about that, really, really bad applications, much worse than any of us are running. Really, really good attackers, much better than any of us are going to face on a day-to-day basis, bought us 6 hours. You can imagine that a WAF is going to buy us a few months while we figure everything out and start reducing our issues. All right? So put the WAF in place, and then do that issue-specific education, right? The sitting duck top 10. Coming out of that, we want to continue to build developer buy-in, again, critical. We want to get buy-in person by person. Here's what it is. Here's how it allows you to make good quality software. When I did the SDL at the financial services firm, that's all I talked about. You guys are rock stars. Yeah, we're rock stars. Awesome. You want to do good code. Absolutely we want to do code. Here's a way you can do good code. And it's not going to take you any more time. That's how you get buy-in. If we criticize them, if we do a lot of things that sometimes, unfortunately, comes pretty easy to the hacker mindset, because we like to play rough, right? We play rough in the hacker community. If we bring that into that, oh, great way to turn them off. Another one thing is sharing the full issue list. Gets back to the criticals, mediums, highs, gets back to having the sitting duck top 10. You scan existing code base, and they see that issue list, and they see that's like 5 years worth of work. They're done. It's done. It's game over. All right, so we scan, we build our list, and then we start transitioning to the next phase, right? So we give them some good policies and practices up front, we give them some training, we give them some code they can copy and paste, we work in their workflow. If they're doing continuous development, we figure out how we can leverage that so that they're still moving fast, they're still moving strong, but they're now moving in the safer direction. At the same time, we start putting in place some SLAs. Look, guys, if we find issues in your code, how long is it going to take to fix them? What level gets what attention? We stand those SLAs up front, so that the remediation is taking place and it's agreed to before we get into this process. All right, so Sitting Duck is now building their apps. They've got their top 10. We've sent all the developers through training. We're now greenfielding everything. We're standing up web services and connecting to mobile. It's not working with BlackBerry because BlackBerry's SDK is terrible. The CEO's pissed, but we're not going to worry about that. What do we do now? As we go forward, we keep scanning with static application security, right? Keep running SAS tests. So as developers are writing code, they get immediate feedback. The quicker they get feedback, the better it is to fix. Because in your brain, it's like doing a pen test, and you've got the entire network in your mind, right? And 6 weeks later, you got to sit down and write that report. I hate that. You're like, what was that one, the box with the thing, and it was something about mileage. No, that's horrible, right? It's the same thing with code. If it's code they haven't touched for a long time, and you're asking them to fix it, forget it. It's a lot of work. If there's a code right now they just did, and it's simple as changing that one line and adding, escape character like Blaster. Easy, very easy. So we do that here. So Sitting Duck, they got maybe 100,000 lines written now. We can do the math to figure out the defect density. They're pushing up code on a 2-week sprint. So we're scanning every single sprint to discover those issues early and resolve them early. That gives us 6 chances, 6 touch points with our development team to say, here's what you did, here's how you can do better. Here's what you did, here's what high quality looks like. Here's what you did, and you know what? That is awesome. I want more people to do that. When we're doing this, again, think about metrics. The nice thing about having like a top 10, a Sitting Duck top 10, is we can see it trending down. If it's trending flat, like SQL injection, we're not going to keep giving them the same talk over and over again, right? We're not making progress. We want those top 10 to be trending down. And the other thing is, we want to start building in some capabilities, some mental muscle, on how to estimate the remediation. Because we know, as things grow, we're going to need them to be remediating things and tackling that technical debt. So we want to help them start building that muscle up now, so that when we get to that thing and we give them a list of 100 things, they go, oh, yeah, 80 days. or whatever it may be, right? But right now, they have no idea. So phase one, that's pretty key as we transition to phase two. Some of the things that we run into here is working an issue list as opposed to triaging and taking care of things the most important. We see a lot of the whole security versus functionality and privacy versus convenience. I am just so sick of that argument. I really wish, I can't wait till the day that argument goes away. My grandchildren, no, sorry. But think about this for just a minute. How is functionality any different than security? Shouldn't good apps function the way we expect them? I would think so. How is convenience the opposite of privacy? Shouldn't convenience be private? I would think so. Why are they not? Because we oftentimes don't do the threat models. We oftentimes don't equip our developers to think about it. We don't give them the time to take care of it. We need to start avoiding that right off the get-go. Let's figure out how to make things secure. Let's figure out how to make things private and functional. And then false positives. False positives. So, yeah. Here's the issue with false positives. This is the quintessential argument you always get. Well, that's got to be a false positive. Yeah, okay, all right. So, do we necessarily have enough knowledge to know that was a false positive before we built the code? No. Do we necessarily know how it's going to be attacked? No. But it's got to be a false positive. Ugh, I hate that. One of the things that we did when I stood up my SDL, and I've done in a couple other programs now, is implement a no false positive rule, right? We will not say the word false positive. We will treat every result as a true positive. But that isn't a vulnerability. I don't care. The static code analysis doesn't like it. We will write our code a little bit different. Work with me here. Because we don't know, right? We really don't know what the static code analysis is seeing in that. And if you think back to those one-liners I showed, very, very few people are going to be able to look at that one line and go, oh, look, there's Heartbleed. It's just not going to happen, right? So, transitioning on, we're going to make sure we keep good buy-in. We're going to make sure we sustain our development, and we're going to start tying things in to the SDL so that we're automating processes. A lot of code today is pushed out through continuous integration frameworks. A lot of static analysis can be done as part of that process. So you push your code, it builds, it runs the test, it kicks it back to the developer so they can fix it immediately. Awesome, awesome stuff. They build the code, it runs, it passes, pushes that into the production of the QA environment, knowing it's safe, which is really, really good. All right, so they're building this stuff, it's working well. We get to the point with Sitting Duck where they've got to take this e-commerce site, the super fast e-commerce site, and they've got to plug it into their old legacy ERP site, right? Because, all right, as you ship things, we got to plug it in and create a shipping record, and it's got to go out to everyone else. You get the idea. And here's where we always run in to the graybeards. Because there's going to be code in that site that no one wants to touch. There's going to be a room in that function and application that no one wants to admit exists. There's going to be modules that keep people up at night thinking if they can change them, all the stuff that will break. Every single application at some point in time integrates to another application that's been around forever that no one ever wants to touch, period, because I don't know what it will do, but back in 1990, we've set this timeout, and I remember someone changed it, 2004, we had an outage and it was bad. No one wants to touch it. So right away, jumping into that, that's like one of our big risks going into this. Hopefully, we built up enough momentum with the developers. They trust us. We can have some conversations about that. Hopefully, we've built up a good ability to do some remediation and some training and some planning, right? Estimating that work effort. But that is, when we shift into phase two, that's always what snags. Is there's going to be code that we just can't touch. So what do? Do we wrap it in a WAF? Do we segment it? Do we put error control at another layer? There's different ways to handle that, but we need to be prepared to have those conversations. And then, too, we can start looking at some of these code problems in these legacy systems and looking at impact and likelihood, right? What are these threats going to do to us? Do we need to fix it? If it's a lot of work and doesn't matter, obviously we don't. If it's not much work and it does matter, we do. And then we start pushing out to our third-party libraries. We start pushing out to new development. One of the things that's interesting is a lot of the vulnerabilities that we're seeing right now, Heartbleed is a perfect example, third-party dev libraries, right? Java, .NET, oh my God, Java. But scanning those libraries and making sure, as part of that build process, right, now that we've got our own system clean, what are we relying on? What is, this e-commerce site relying on over here that we borrowed over there, and we download this module over here, and this thing's over there, scanning all those and reducing those problems. And then putting new projects through that. So, as I mentioned, legacy code is a big problem that everyone has. No one maintains it, everyone uses it, no one wants to touch it. The other thing I always hear about is it exploitable? I think it is probably in the textbook of modern day software development curriculum, like 200 level class that they teach aspiring developer managers, which seems like an oxymoron. I think if you're a happy developer, you probably don't want to be a manager, but no, I'm just getting nostalgic for when I was a developer. They teach, like in a 200 level class, how to handle the pesky security guy. And how you handle the pesky security guy is the same way that we handle criminals, right? You raise the cost of the adversary, so the adversary goes away. 101 security thing. That's what developers do. I hear this time and time again from the dev manager. Well, that's a great thing. And I understand this no false positive rule, but is it exploitable? Can you exploit that? That's a great question. The challenge is that raises the cost to us, right? Whenever we move off a static analysis tool or a dynamic analysis tool, and we engage a person, that increases our cost. So we need to start doing some serious conversations about that. It's going to cost X to test that. It's going to cost you Y to fix it. Like this? Let's just fix it. Is it more like this? Okay, let's actually do some testing. But it's a conversation that comes up every single time. Is it exploitable? Prove it. Prove it. So we look at the time, we look at the impact, and we make a good decision. As we move on to future phases, we want to start making sure code coverage, right, the amount that we're scanning statically, both the code we've written in our modules, reaches about 75% and is managed. We want to make sure automation is in place. So again, if they're pushing out with continuous integration framework, here at Sitting Duck, we use Puppet. We've plugged into that, and it's checking it as the code goes live. As we transition, we're going to start thinking about the new Sitting Duck Top 10. We want to start thinking about the ways that the developers have started using this software over the past year, right? So we want to start thinking about these things and really tune the program in to how they're working and make it even simpler, right? If we can get to the point where Sitting Duck is unsinkable, because they're writing good code, that is only going to happen by then taking that software that we've been running in more or less a generic way and following the OpenSAM or BSIM and really dial it in very, very finely to how that organization works. How the developers work, what's their cadence, what's their pace, what's their culture, and tuning it into that type of company. So phase 3, now we've run static analysis, we start doing some dynamic analysis. We integrate with QA. So static analysis and dynamic analysis. Static analysis runs across the code looking for known vulnerabilities, right, at the code level. Dynamic analysis runs across the application looking for vulnerabilities by basically doing brute force attacks, right? Try every single input box, throw something crazy at it, see what happens. What I've seen was really cool with dynamic analysis is if people take your QA scripts. So the QA has a series of like burp scripts or whatever, and it's, click to this, click to that, click this other screen, tip this stuff, tip that stuff, and it follows the whole way the application is supposed to be running, and then tries attacks through that every single step of the way. Great way to do it, leverages the QA environment, leverages all that information, and gets much deeper into the application. What I've seen work horribly with dynamic analysis is vulnerability management guys. Does anyone here a vulnerability management guy? Before I say this. No, vulnerability management guys, right? If you're a Windows vulnerability manager, what do? You say, I want to look at that IP address with these creds, click go. And Rapid7, Qualys, you name it, will scan that IP address and tell you all the bad stuff. And then you go, okay, I will now patch the bad stuff. That mentality works horrible for static or dynamic analysis. Look at that IP address and go. So think about the last time you went to any web application, didn't click on anything, how much did you see? Nothing, right? They'll scan like the login page and go, you're fine. You're like, yeah, your code's clean. No, you're not. So using those scripts, the QA scripts in the dynamic environment opens up the app way, way further. And then we can start really beating the hell out of it, right? Because when they're writing features, you're creating your code for those features, that's where you find your bugs. Your bugs is your defect density. That's what we've been talking about for almost this entire talk. That's what static analysis will find, that's what dynamic analysis will find. What static and dynamic analysis will not find, just like a vulnerability scanner, again, running across an IP address, big difference in a pen test, right? Because that'll tell you where your flaws are, but that's not going to tell you where the mistakes that systems administrators make, the architectural decisions that they make, right? All those other issues. Architecture, the fundamental design of the application is where you get your flaws. Static analysis and dynamic analysis will beat the hell out of the bugs, which we can defend against using training and coding practices, give them the right code, give them the right training to address Sitting Duck Top 10. Flaws, that's architecture, right? That's design. Those are only going to be found using things like penetration testing. But oftentimes, you're not going to be to a point where you can pen test. So you're pretty far down the life cycle, right? The application stood up is pretty well. It's installed. Pen tester can get to it. We got an environment. We know how to reproduce it. So at that point in time, that's where we really bring in the big guns. They compare against the threat models. They look at authentication, authorization. They do patterns and security considerations, and they beat the hell out of the application. So I already mentioned this a bit because I'm kind of skipping ahead because I'm running low on time. But QA artifacts. Some of the things that we're going to find here is, wait a minute, you guys said we're secure. We're fixing all these bugs. Now you're telling me I've got a flaw in my authorization model? Yes, you do. Sorry. We need to give them enough foresight, right? The executives, the development team know that security will continue to test deeper and deeper as the application gets built. Because otherwise, they're going to reduce all those problems, all the static code analysis, think everything's fine, and then we're going to turn loose a pen tester, and they're going to find a whole bunch of stuff, and they're going to be like, what the hell? Why did we just spend all this time, fixing these things? I thought we were secure. All right? From that, we can then go on to the next step, which is tune this directly into the Sitting Duck comp and finish it out. This is looking at consistent application risk management, basically applying ITGRC concepts to your apps. This is looking at custom rules for SAST and DAST. We know how our developers are writing code, some of the common mistakes they're making, or maybe we put in place some style guides or different levels of quality. And we can then begin looking at all the SAM to raise each level up to 1 or 2 at a minimum. So, we looked at the gap assessment, we applied it, right? We saw the problems, we spent a good 1.5 years with Sitting Duck to address the various issues, and through adding specific topics every couple months, improve the developer quality without adding time to their workload, improve the quality of the code, reduce the vulnerabilities. At the end, we got a SDL that looks like this. We're hopefully doing some threat modeling. We're doing a lot of software testing with SAST. We're in their IDE, so as they're typing, we're giving them real-world errors. We're doing the dynamic testing in the environment with the QA scripts. We're doing some penetration testing. When we deploy, we're going to continue doing DAST, right, the dynamic test with those QA scripts to make sure there's no changes that have slipped through and went through this without following the actual change process, right, which never happens. Who's going to push a change without the process? But just in case, we'll do that. The other thing, too, is, again, CircleCityCon, right? Here, in the next few days, there's a vulnerability or some cool trick or some new way to break apps. It's going to be released. It's going to be discussed. Those types of things get codified in dynamic analysis tools as rules. So we want to constantly be rescanning our existing code base when it's on life support to make sure that as new attacks come out, we can address them and reduce them. We're going to track it all by defect density. And hopefully over these phases, that defect density has been going down and down. That shows us that the developers are getting it. They're in a place of cultural awareness. And that even if we step away, we take another job, the folks are still doing the right things. Cool? So in conclusion, right? That's a lot of talk. You write a line of code, we create bad things. Right, lots of lines of code, push on lots of devices, we got lots of bad things. Fundamental way to address this is culture. And culture is built one action at a time. It's built on one conversation at a time. It's built at one story at a time. It's also built at one line of code at a time. So we can get to the point where we are looking at these lines of code, we're looking with the developers, we're doing the right things time and time again. We can look at each line of code as a way to develop a security culture. We can look at each function and feature as a way to have a conversation with our developers. We can look at each one of the things that they're doing as one small step, one more drop in the bucket to get sitting duck to a better place. Okay? 5 takeaways, I'll leave this up. I talked about Security Culture Framework, SCF. Take a look, it's available. The SDL, Microsoft has a huge one. I did not list Microsoft's because I think it's a little bit too big, but take a look. They got lots of great guidance, especially if you're a .NET house. SAS, DAST, and application pen testing. BSIM and SAM are both available for download. Anyone have any questions? Great. Oh, yes.
So I actually have two separate sets of questions. So one of them is, so I know at the beginning you're talking kind of the top 10 and stuff like that. But, and I'm not saying the data is correct.
Yeah.
But the government of Australia in the past, like I think maybe a month or weeks or something like that, has released that they've implemented what they say are, they said if you go to Qualys,
right,
top 4 security controls, they, the link is actually back to the government of Australia, and they have said that they have reduced the number of attacks that are successful in, against their networks dramatically. I mean, go look at these charts.
Oh yeah.
Google it. So it's reduced it dramatically, and from a defender's perspective, reducing the number of things you need to pay attention to, not that I think that they are correct, the number of attacks are like gone, right? The number of attacks they know of and have defended are reduced. So the number of attacks their, InfoSec people need to concentrate on, which are the ones that are unique,
right,
the ones that are important, they're able to focus on. So is that not a top 4 that seems important?
So there's actually 2 different things I'm gonna give you 2 answers.
And I'll give the top 4. So it's application whitelisting.
Yep.
Patching of operating systems,
Right.
patching of your, applications.
Yep.
And then least privilege management. So, whatever the thing is the process is doing, doesn't
Right.
have least privilege, including the person,
Yep.
logging in as administrator on their Windows box or just least privilege management.
Perfect. So the main question that I'm hearing is 2 different things. One is, why are you down on the OS top 10? So I'm going to cover that. And 2 is, doesn't giving us a list of top 10, top 20, top 4 help us?
Right. Is there not a top X
Yes.
that is effective?
Yes. So I like the OWASP top 10. I subscribe to the OWASP top 10. I talk about the OWASP top 10. We held a meeting to cover one of the OWASP top 10. My challenge with top X controls, so I'm going to leave OWASP, I'm just talking at the big level, is not that they exist. I love that they exist if they are focused in on real-world risks, if they are followed, right? So those top 4 are great. If there's like 10 attack paths, and those 4 are covering 90% of the risk, now I know what to do.
Australia says 85%.
85% says Australia for the top 4. But, Australia, and in that example, people who are following that are doing the one thing that frustrates me with the OWASP top 10, is that we have this great OWASP top 10, and then developers don't use it. So, and you mentioned Qualys. What I love about Qualys is, I can take the top 4, top 10, or whatever it may be, and I can say, scan everything and tell me if people are doing it. If they're not, let me know who they are so I can talk to them. That's good. If you have your top list, and A, it's risk rated, and B, it's then acted upon, you're in a great spot.
So my second question, and also I was saying, I think the top X reduces the signal to noise.
It most definitely does.
For the people who need to pay attention to what's important.
Mm-hmm.
Let's say there are, I'm pulling out of my head, population of frogs in a pond.
Okay.
Biology has algorithms for figuring out how many frogs are in the pond by capture and release or capture and kill.
Yes.
So have you looked at the idea of replacing defect density with that type of algorithm or that type of methodology? Because defect density is looking at what your software, what you know. These algorithms are looking at beyond just what you know, but what you can capture and understand, and using an inference of mathematics to figure out what the real defect density is based on, for example, the capture and kill. It's like you capture a certain amount of animals and you kill them.
Yeah.
And then in a future X amount of time, you go back and you capture the same amount of animals. So you use an algorithm to figure out what the population is, depending on the difference, not difference, but the...
No. I think this is brilliant. We're going to, and I may need some people's help in this room. We're going to go out and we're going to capture a certain percentage of threat actors.
Right.
And we're going to kill them.
And I don't think that the capture and release is possible.
No, definitely.
It's definitely a capture and
We will find these guys, and we will kill them and count them. No, I actually want to talk to you more about that after this talk, because I'd like to hear more about that algorithms, and the short answer is no. Defect density, what I like about metrics is if they're very simple to explain, and defect density I find is very simple to explain. You're at this many lines, this many are normally bad, you're at above or below. But I want to talk to you after this, because I'd like to hear more about that. We are right up on 7 o'clock. Anyone else have any questions? Wolf?
I just have one more, because I've seen this same situation going on now for a long time too. You made a comment early on about the fact that we have the same problem. Nowhere is going to the top end for a decade now, right?
Yep.
And like you said, we're still producing these same 22-year-old college graduates that are still writing the same type of bad code. At what point do we as a security community go back to the textbook manufacturers and restructure and say, look, why don't you start teaching how to do good code to begin with, instead of us having to go to our developers and start working on retraining them now in industry? And I work in a dev shop, so we're going back and retraining people how to ride a bicycle when they could have been taught how to ride a bicycle.
I go to 1 to 2 colleges a year, and I give a talk I call Surviving the Robot Apocalypse, which is the kid version of this. And by kid, I mean like college kid. And I talk about how to bypass cyber vision. And, do you ever see the Terminator and he's going to shoot you? Well, he's just going to shoot you this way. And these are the lines of code that's probably doing it. And here's how input validation works. So absolutely. I think the more often we can get engaged, the earlier, the better. And you know my daughter, right? My daughter.
I just think it's something we have to involve
Yeah.
educators, education to discuss it, because like you said, and I see it, we're producing the same 22-year-old college graduates that write the same bad code,
Yep.
the same bad mistakes.
That's why I go to colleges. That's why I dean the CBI Academy, because the earlier we can get to these people, the better it is.
I agree with the need to education become developers. I think that's part of it, but I think we can also find in these slides. You definitely have to have executive buy-in, because if we do train and give young developers the right mindset and habits, if they go into a shop, they're working on role models for such a long time, and they do it, they're really doing the life
Yeah.
We've seen these people, I think to solve it all together, so. Because they are going to be going to the dev shop to go.
You got to tackle it from both ends. You got to tackle it from both ends. What I like to see, colleges who do English paper writing have like these autograders. Have you guys heard of this? Where you write your paper and then you throw it to an autograder. An autograder would give a rough cut. And if it's below a certain number, the teacher won't even look at it. If it's above a certain number, then they go ahead and they actually will read and grade your paper. And they had to do this because of the scope and breadth now of all these online courses. Wouldn't it be great if the autograder for developers turning their code ran SAST on it? And automatically found all the defects and kicked it back. That would be awesome. I would love to see that. But you're absolutely right. So we got to do it early, and then once they're in the field, we got to be engaged with the development teams. Anyone have any? Yeah.
problem with don't grade on security.
Yeah.
And they might throw in one class in an entire 4-year program on coding securely, but everything you did before and everything you did after is get it done now, get it done fast, meet the functional parameters, and that's all they grade on.
Right.
They don't care if it's secure.
Nope.
They care if it does X, Y, and Z and does it properly.
Yeah.
And that's a fundamental shift. Because to code securely, it's typically means you have to code a little bit better.
Yeah, a little bit better and a little bit more.
You got to think about it.
Mm-hmm.
You don't do that in college. And that's a fundamental shift in how they teach it.
Right.
There's probably the education system because I still take classes. And I had an instructor actually ask me on one of my programming classes, why I was doing the input validation I was doing.
Yeah.
And I'm like, because of security.
Why are you adding these extra lines? It would be much more elegant if it was shorter.
We have these hackathons now where they build apps quickly.
Yeah.
Okay. I was taking part in one of those. Security wasn't even an attribute they were doing.
Not at all. And that's the other thing.
Functionality and usability.
Yeah.
Never security.
It's going to take a fundamental shift at the development space, in production, across the board. Or otherwise, we'll all be employed for a very long time. Last question.
Well, it's not really a question, it's a response. Since I'm one of the people you're kind of bashing on over here. I'm faculty instructor at the university.
But see, he does it right. Go ahead.
Well, I mean, and we're actually sponsoring this con.
Yeah.
You've got to realize that there's a lot of pressures there. I teach security as part of what I teach my development, but the point is that a lot of students teach them, they forget.
Sure.
You know, it's just like any other thing. You teach them, they learn enough to test or whatever the case is, and then they forget. There's also pressures of some of the older guard don't believe that testing is important. Others, obviously a little bit younger, believe it. So you're seeing a change, trust me. As newer, younger teachers come into play that are more connected, you're going to see more security, but it is still hard. There are pressures there.
I just want to say one real quick thing on it that I'm doing. So you teach them and they forget, right? I'm so embarrassed to say this, but I'll say it in front of all you guys. So I actually took like this web application, like, pen test. I'm like, I talk about SQL check all the time. It took me like 3 hours. And I was talking to my pen test. I'm like, wasn't that tough? In the textbook, it's really easy. He's like, how long did it take you? I'm like, why? It took me 3 hours. It took me about 5 because I'm sure yours was really well documented. So you learn, you forget, right? We look at social engineering. There's a social engineering shooting fish in a barrel.
Yeah, tomorrow.
Shooting fish in a barrel. Her whole point was you teach people to not be fished. 6 months later, they forget, right? Everything in here, a lot of times, if you're not using it, you're going to forget. That's why I like life cycle, is how can we repeat these lessons over and over again? Because the average time and you're an instructor, I forget what it is, but it's like 180 days for retention, 110. It's real short. I will have to talk afterwards because I got to cut.
Yeah, we got to follow up. I think we're going to be closed up.
Yep. Thank you, everyone. Have a good one.